It's the strangest thing, but when you log in, there's this lady who says this meeting is being recorded, and my dog does not like her voice. She leaves the room every time.
Better record that voice and keep it handy whenever you need it.
Yep, I don't get it, and so I try to remember to lower the volume because I know she's going to say it, and this one gets scared. But sometimes I forget, and she just whined and left the room. I don't like that.
I'm sure there must be an option for a different voice.
Yeah, maybe. The thing is, I only use Zoom for the OCP meetings. Everything else is Teams where nobody says anything. So I've been, I guess, too lazy to go figure out how to change that voice. But it's something about that particular frequency bothers her. She can put up with the loudest sounds, and then there'll be some small beep somewhere. Total freak out. Okay, we'll give it one more minute. Okay, we've got a reasonable audience. Let's get started. Cliff, you are here bright and early. Do you want to? I'm sure you have stuff to say, so I will hand it to you.
Sure. So thanks, Anu. I wanted to remind everyone that we have the Innovation Village proposals open until July the 11th. So Anu, I think you're working with Jawad and maybe the rest of the community to put in a combined proposal for open chiplet economy. It'd be great to see that. Secondly, let everyone know that
Okay, Cliff, let's just take a step back. So I am sorry to disappoint you, but I haven't done anything about the Innovation Village. So let's just get into some details so I can actually take care of it. Um, can you explain to the team what we're looking for? Similar to last time, I'm guessing, where we get a space and yeah.
right. Well, the Innovation Village is pretty standardized, and it's about non-commercial pre-product demos that we put on the show floor. Uh, this year, we have a pretty good size allocated for it. And like last year, we hope to see a good representation from the open chiplet economy. The actual fee for presenting there's no sponsorship required. It's by invitation based on the proposals. However, the people that do come to demonstrate are committing to have at least one or two people there for the exhibit that's open the entire time of the exhibit floor. So it's a couple of days. And and so there is a commitment not for sponsorship, but effort. And, if you wanted to, there is some equipment potentially. I don't recall on the equipment if there's no charge for the table or electricity or anything like that. And we're looking for those forward-looking demos, which we know the chiplet work is, and we'd like to see a very coordinated set of demos for the open chiplet economy if possible, like last time. I know it might be good to share with people what was the demos from last year, and so people could understand what they might put forward. That's the best quick explanation I could put on it. Many of you probably participated last year, so you understand that. But if there are questions, I'm happy to do my best.
So Cliff,
Yeah, so
I can add one thing, which is for startup companies, it's an excellent opportunity because a lot of the work that they are doing is pre-commercial stage and there is no fee to pitch them. So it's an ideal opportunity for anyone working on early stage commercial ideas.
Yeah, I don't think there's any other event where you could get this much exposure for so little cost.
Cliff, do you happen to have what we had that put out last year, just so the team can see?
I'll have to look for it, Anu. I can try to find it in a few
Yeah,
minutes. It
great.
should be-
If you find it, then I can just send it out to mail it out to the team.
that would be good if you could.
Yeah. Because I know that last year there was a lot more traffic through that area than the previous year. I've only been to the global summit like probably 3 times. So just relatively speaking, I noticed last year it was a lot busier, and I think they located us sort of nicely.
And this year again, it's a nice location. And this year there'll be one section which is the pre-product demos from the startups and F the FTS work. That'll be for one section. Then there'll be the project section in the middle, which was where the OCE would be. And on the right, they're actually going to have some collaborative demos showing some integrated work across the project. So it'll be quite a large place on the show floor. So it should get a lot of attention. And for those of you that don't know, we had 7,000 people attend last year. This year, our projections are closer to 9,000. So if you had a lot of traffic last year, we should have more this year. Hanno, can I suggest that you share last year's Innovation Village plan on the Groups IO channel with everyone so they get a copy with an appeal for them to maybe send to you or you and Jawad a proposal so you can maybe um,
Yeah.
integrate them all into one and put that in as a proposal?
Yeah, that's what I had actually thought about this yesterday about pulling that up, and then of course everything went out of my head. Um, so that's probably the best way to go about it. I know that a lot of folks on this call they've done this before. I think Kevin has for sure. I know Cash has, but I don't know what the status this year is for a lot of them.
And likewise, it's also great. There's fine to have research labs show their work as well. Sorry, Kevin, you wanted to ask a question.
Sure, just two quick questions. I know that OCP Global Summit is a day longer than before. Do you have any idea if the exhibits are still going to be open Tuesday and Wednesday like they were in the previous years?
They opened Tuesday afternoon the previous years, right?
Right.
And they were open Wednesday and Thursday the previous year.
And Thursday, you're right.
So it
Correct.
would be the exhibits are not open any longer. What's happening is on the first day on the Monday we're starting in the afternoon instead of on the Tuesday morning, and in the afternoon there'll be some co-located workshops and there'll be some keynotes on the Monday.
Is
But
it okay if
there'll be no exhibits on the Monday.
no exhibits on Monday? Right. The floor opened at like lunchtime on Tuesday, as I
Right.
recall now.
Usually open. Yes, we usually do not open the exhibit to compete with the keynotes, so we open it just
Right.
after the keynotes. Yeah.
Is it okay if I share something? I knew it's your
Yes, of
meeting.
course.
I don't
Which
remember
is more than I can do
if
today.
this is
So
final, but this is what it looked like last year. And So when you say proposals, I think what you mean, so there's a bunch of different, in the village, there's a bunch of different people. ODSA is now OCE is us. So we need a proposal from this group is what you're asking for, right, Cliff?
That's exactly right. And you could see that those demo tables, I believe last time we had 2 stations per table. And so
Two stations per table.
you would have had three, six of, maybe 10 or so different demos in that area. And we're hoping to see the same thing again this year.
So is it you're looking for a coordinated proposal from OCE, but from say Anu and Jawad? Is that the right understanding?
That would be the best way to do it than sending in
Okay.
individual ones, yes.
And then Anu, you're trying to solicit whom from this group is interested in doing a demo so you can put that
Yeah.
together, I'm guessing.
Yeah. And as Cliff said, for the startups, this is sort of almost a relatively free space. You just have to bring your own equipment and demo, which is hard to find without additional costs in any other circumstance. So,
And also I'd encourage some of the research labs like LBL, if there's a demo that they've got that they want to show, that'd be around chiplets, that could be fine too.
And then if I can add, in the past demos, Elian, for example, did a silicon demo, but I don't know if David's here, but he did one that was software or showing how his 3DX worked. So, demos can have a wide variety of forms they can take.
right. And Cliff, did we even allow for a poster last time, or sort of a work in progress towards a better future type thing?
I'm sorry, Lano, I didn't understand. You're asking about a poster?
So I think the answer is yes. I know UCLA did a poster. So
Okay.
the demo could be something that's, as Cliff said, a view into the research,
Yeah.
for example.
Yeah. Yeah, which allows folks like LBNL, if they've got anything they'd like to share. And I think if you're especially soliciting for resources or more people to join you, that might be a good place to do it too. Okay, so Innovation Village, I'll try to send out what the demos were last year, so everyone gets an idea of what there was. But feel free to please reach out to Jawad and me if when you have a plan, so we can put that together and send it to the OCP. Okay, that's topic number one. Cliff, is there any other topics that you have from the OCP?
Just to let people know that if you haven't already, Anu, that we have secured a full day for Open Chiplet Economy again this year. We had, I think, about 24 or 25 proposals for speaking come in, which was healthy representation. And that'll be on the Wednesday of the conference this year. So we were able to put that in the middle of the conference rather than the last day. And I know I hope you and Jawad and the rest of the community will encourage lots of folks to come on out and be in the seats and listen.
Yeah, no, for sure. And I think there's a few people who distinctly felt that being on the last day is not helpful, especially the second half of the last day, because most people are getting their flights out. And so being in the middle, I think will help us get more traffic and more audience. So we appreciate moving us to the Wednesday as opposed to the Thursday. So that's one piece. Then the APAC summit, I think it's just a matter of reviewing papers now, right, Cliff? That one also.
We do have a full day on chiplets and advanced packaging for APAC Summit. I will say that for whatever reason, and it makes understandable, the representative from this community is going to be Jawad plus myself at that full day. Most of the rest of the people presenting, I believe, came from invited speakers, and a good number of them from the region, although not all, because we do have a presentation on UCIE from Devendra that's going to be done in the track. But there is going to be a pretty full day of top level speakers representing under OCP banner. Quite a number of folks from ASC will be talking, which we're very happy for their support. And we also don't know yet, but we have invited TSMC, and it is possible they will send someone to speak as well. Although that's not confirmed 100%, but they're discussing internally still. But we're hoping that they will come. The good news is the session will be recorded, and so please look for that in the first to second week of August to be available at the past events website. And I would encourage everyone here to take a listen through the recordings and the presentations from that track.
Sounds good. Thank you. So that takes care of Global Summit, Innovation Village. So the Global Summit, we will, Jawad and Cliff and I will sit together and put together a cohesive program, hopefully. We would still like to solicit for, dynamic speakers who can help us gain audience for our full day. I think we like to start with somebody who's can pull in the audience, and maybe one in the afternoon or a panel in the morning or the panel. So we've got to figure it out, and so there'll be lots of, I think, conversations as we get this
So
program.
I just want to set some expectations. There's about a 50% oversubscription.
Okay.
So
Yes.
probably what we're going to be able to do and justify is, maybe if we can get a very starful keynote speaker or something to kick off the morning or something like that. Most of the rest would have to come from the proposals, I think, that were already submitted, as long as there's enough good quality ones.
Yeah. And we might have to do some combination to make sure that we highlight all the key aspects of the work we're doing too. So.
And we can do that too, yes.
Yeah. Okay, that's good. Another thing I wanted to briefly bring up was the ChipCon 2025. It's an IMAPS conference. It's the week after July 4th in the Bay Area, in San Jose. We do have a half day where we've got a couple of speakers who are on this call actually going to be talking about the chiplet economy. And when I look at the stuff they put together, NLCO is the organizer, not from the IMAP side, but the technical organizer. It's actually a really good program. So take a look at it. I did send an email out to everyone. The IMAPS is willing to offer discounts to certain people, and hence you have to email the individual that I put in my note to everyone and see if you qualify. The OCP has all sorts of members, from individuals to startups to hyperscalers. So they want to make sure they give the right people the discount. They want to encourage folks to come in, and I think it could be really useful. So take a look at it and make sure you email her to ask for it, because I did complain about how all these conferences get pretty expensive ultimately. And they were very kind to say that we understand and we're trying to get a broader audience too. So it works in everyone's favor, ours and theirs. So take a look at that program. I'll actually send the link out later as we talk today, and see where we can go with that. Any questions about ChipCon? And then the next thing I wanted to talk about, and I wanted to ask you, Cliff, we did on Tuesday, earlier this week, we did the Open Systems for AI. And I really want to thank everyone from our team who participated and put the slides together and showed up on time and gave their talks. And what I liked about that was it's a broader audience who typically doesn't attend Chiplet conversations. The one question I got when I started talking was, what's that interface you're talking about? It was the bunch of wires interface, and I just say it assuming everybody and their brother should know about it, but there's really no reason they should. So I feel we reached a wider audience, and I just wanted to know from Cliff, and Rob's not here, but what the feedback was, or what happens next, and how do we get more traction in our team?
Well, thank you, Anu. So I think there's a couple things. One, there was about 60 to 70 people that listened in, which was very good. I think that the thing that you can do to keep talking to the broader audience is we have a monthly call on the AI Strategic Initiative. And as work that is relevant for AI and we can position for AI goes through the contribution process here, you can ask myself to get a slot to speak at the monthly call, which will give you a broader audience. That's one thing you can do. Secondly, we haven't done it this year, but in the previous years, we did some virtual workshops where we invited we did it virtually and we invited folks. And I think that's something maybe we could think about for 2026, doing a couple of those where we invite the entire OCP community and we have like 30,000 people in our mailing list. So we could really broaden the audience that way by doing that.
Yeah, that might be good because, chiplets are sort of a shoe-in for AI-based hardware systems, at the high data rates and the requirements, and especially eventually they get to optical. It's all going to be a chiplet-based story. And I don't think people at, different levels of this hierarchy, because we are sort of at the bottom of it, truly know or understand. And some of them may care to understand. And so that might be a great idea, Cliff, to do that next year, or since you suggested it.
Right, because there's a lot of folks that they didn't necessarily, we didn't have a lot of representation from OCE at EMEA Summit. And we do have other groups like Storage that actually doesn't focus on EMEA. They do a virtual workshop in the spring. So maybe for OCE, we do a virtual workshop in the spring. Think about that. And that way there could be a very wide attendance that we could bring.
Yeah, no, that may make sense. It's, I think, hard for us. I mean, now the OCP is, expanded to so many different regions. A little bit harder for us to get around to all of these, but a virtual one is a lot easier for the speakers as well as the audience. And ultimately, I think the job is done similarly, or not quite the same as a face-to-face, of course, but in a manner of speaking, where we actually get the information across. Any comments from last week's? Any requests? I know, Raghu, you did a little pitch there for folks to be interested. I'm trying to figure out how to push that along. I need to bother DJ one more time this week about our resource request, but
yeah, at least the two work streams that I'm active participant, I think getting some more exposure, and also only more like almost a formal. I'm pretty much calling it for a formal call for proposal or a call for participation. So we get best set of and right set of industry participants. For that, I would definitely need OCP support. I think I already have made it very clear in the presentations on Tuesday. Otherwise, just going through our own personal networks, I think it does not be the right thing to do first and foremost. So I think that's what I need to work with you, Anu, and whoever it is that we need to see if how can that be accomplished. I'm not sure if you want to waiting till next year it's okay if that's the case, or wait till OCP Global Summit, it's okay. But I think if we want to
No,
go fast, we need to
I
think
think,
about it sooner than
yeah,
later.
I think maybe what we need to do is we need to set up a separate meeting with Cliff so he understands, maybe Cliff and I don't know who else from the OCP, Cliff, to understand what our needs are and then, guide us down how to go about it and put the request through to the wider OCP, which is a ginormous audience.
Yeah, we can certainly look at doing something to promote the particular work stream and include it, a call to action to join and see, that would go beyond your personal network and would help potentially grow the effort.
Right.
Yeah.
Correct. Yeah. I think Cliff, I'm not sure how much you caught the presentations on Tuesday, but ideally it'd be great if you can just even issue a formal call for proposal or a request for information, right? For some of these frameworks, open frameworks, we have to have good alignment with the industry players. Otherwise, it's not going to happen.
Yeah, we can
Right.
I didn't have a chance to catch all the presentations on Tuesday, but we can potentially use that and the recording from that and do some promotion around it and with a call to action to join the work stream. We can look at formulating something like that and put it in the monthly newsletter from OCP to the community.
Okay, that'll be fantastic. Yes. Right. Yeah.
So
That'll be great.
we need to provide a write-up for them, Raghu, that they can then incorporate into the community news.
No, I'm glad to hear it. I mean, I think coming from you, Cliff, I think that makes a difference. I was just trying to see how to get to that spot, but if that is a possibility, and I think then let's try to do it. Let's do it.
Yeah.
Similarly, I think Anu, you're trying your best to get some kind of profiling
Yes, like
resources,
I
right?
said,
I mean,
I
again,
had to bug DJ again.
yeah, but again, I'm trying to see if this can be somewhat more formalized,
Yeah,
to get
understood.
it through some proper channels, so that
Yeah,
this
I
can be
mean, if
properly deployed
my
for OCE use, right? So we're not like begging, borrowing, and leveraging and
I
all that.
understood it. I just figured if DJ can't help us, no one can. But you know, I think DJ has probably many different things going on in his life that this may not be. Um,
Yeah. So sorry, I do need to drop, but I'm happy to maybe after the week of July 7th or the week after, we can have a call and put together a bit of a communication plan around how we look to leverage the videos that we created and maybe do some sort of call to action for people to get engaged.
Great. Thank you, Cliff. Means a
nope,
lot.
that sounds terrific. Thanks, Cliff. Thanks, Raghu. And Raghu, I am going to let you take over, introduce Kamal, who has joined the call. I have successfully wasted 30 minutes of
No,
everybody's time this morning. So it's
all
all yours.
all good discussion. Let me see. I think Kamal is not yet. I can see Kamal
He
out
is
there.
here.
It's
I
not
see
come on
him.
audio. All right.
I'm here. Can you see me? Can you hear me?
Yes, thank you, Kamal.
Okay.
You're the man of the hour
Yeah.
or the half
Okay.
hour.
We'll try and make it worthwhile.
No,
Sorry,
no.
Anu.
All good,
Oh
all good.
yeah,
Hey,
you
so
you better do, Kamal. You're on the hook here now.
hey, so
We'll
let me
do
do the
well.
quick introduction. First, thank you, Kamal,
Yep.
for coming and sharing your presentation today. First, thanks for that. Took a while, and I also want to thank Rashid Kukadi, who I can see online. I think he was here some
Yeah,
time
yeah,
back.
I'm here. Yeah.
Okay, hey Rashid. So thanks. He I think also was really instrumental in making this happen. And then Anu also for moving this to a prime time slot, right? So more people can listen in. And the background is that a lot of work streams are working in some form of chiplets or multi-die designs. And many work streams are at a stage to evaluate the goodness of chiplet-based systems or benefits of chiplet-based systems. And now all the participants are experienced in the semiconductor space in some shape or form, but virtual prototyping might be new, or architecture modeling and design space exploration might be somewhat new. And so it will be good to have a very baseline. So Kamal, when you present, just assume that people are know tech and semi, but possibly may not know virtual prototyping and definitely probably not platform architect. So just start as an intro info session so that folks out here can understand the possibilities with an open mind. And basically the next step would be in our own respective work streams, we can consider if this could be a good vehicle for evaluation of chiplet-centric ideas and concepts that are kind of cooking around in a couple of work streams, right? So that's kind of the basic. And so the way I'm going to set up this is that let's give a continuous 30 minutes for Kamal to present so that at the top of the hour, hope people already have joined in and can listen in to the whole presentation. And then after 9 a.m. Pacific time, if the people who want to stay on and ask some Q&A, and then we can keep it that way. So just hold your questions to the second half. That's my request. With that being said, thank you, Kamal, and I'm going to hand it over to you.
Okay, so thanks for the introduction. Yeah, so I met Raghu at, I think it was Chiplet Summit, the Chiplet Summit a couple of months ago, and Rashid as well. As met Anu as well there. So they attended some of the presentations that I gave. So I'm going to assume that, okay, you said no one knows virtual prototype, but I'm going to assume everyone knows about multi-die and chiplets. So I'll skip all that part and
Yes,
probably make
correct.
it more worthwhile and just focus on the virtual prototyping aspect here. Let's see. Okay, so I hope you can see my screen here.
Kamal.
Okay,
Yes.
great. So then let's just get into it. So, I mean, I'm only at half an hour, but I think I'll just focus on the main aspects of what virtual prototyping is in the context of, multi-die systems and why do we actually see it being relevant and important. But then I'll also go into an introduction of platform architect. So there's a couple of angles here. One is just platform architect, early architecture exploration. What does it mean and when do you do it and why is it important in the whole chip design flow? And then the second angle is really applying that to chiplets. Okay, so I'm going to skip this part, right? Everyone knows what multi-die is. Everyone knows what chiplets are for. Everyone knows homogeneous, heterogeneous. So I'm just going to skip all this. Sorry. In the interest of time, right? Why are chiplets and multi-die important? I think everyone gets that now, right? So let me just skip through these first 3 slides and then we'll just go straight here to the platform architect value proposition. So if you look at your typical chip design flow, right? You start with some kind of functional spec, some kind of specification, you then move to an implementation, then you get to place and route, and you get to your fabrication. So in essence, this is a simplification of the whole flow itself, but it's the steps that you have to go to, right? And the tasks that you would do at this early specification phase is, the architect is looking at some type of specification, whether it be Excel sheets, Word, whatever it is, it's in someone's head, and they basically come up with estimates about how your design is going to look. What are your memory blocks going to be? What are your interconnects? How are they all going to be connected? What are the cores? What are your peripherals? Whatever it might be. But at this very first level here, the architect is putting together the design. You move along, now, okay, the architect has an idea, maybe has some idea of some of the workloads, some of the software that's actually going to be run on this design. Now you start moving into, what we call validating the performance. Okay, so maybe I have access to an emulation system or a RTL simulation system, whatever it is. But the point here is that you want to start validating your performance as the next step once you've created your design. And then further along, typically what we see most customers, most designs do is, once you get now to the netlist phase, this is when you start thinking about power, right? And then you move to tape out, right? So in essence, this is really the flow that most designers typically do. And now with multi-die and chiplets, you're actually seeing this being more complicated, right? There's a lot of trust put into this very first phase here of static estimation. Now, my next bullets here, really, there's issues with this, right? So there's unpredictable performance and power due to dynamic effects. How do you know, when you start actually putting your system together? Yes, I have an idea of a memory block and an interconnect, but now I start putting many of these together. Can you actually figure out what are the effects of all these blocks together? And especially here from an architecture performance perspective, you really care about your memory utilizations, your latencies, any arbitrations, and so on. The other thing that we've, maybe 10 years ago, people really didn't care about this. Hey, I just go to Intel, AMD, I got a chip off the shelf, and good luck to you. What we're seeing now definitely is that every chip design is driven by the software, the application, or the workload, right? So this notion of optimizing your chip design for a particular application or workload is really key now, right? So many vendors, many designs, they're creating AI accelerators, whatever it is, but for a particular task, right? It's not a generic SoC, it's not a generic chip. So this whole notion of optimizing our application or optimizing our architecture for the application on which it's going to be running. And then similarly, right? So here we've got this serial step. First, I'm going to look at performance, then I'm going to look at power. Why don't you look at all of that together? So typically in this flow here, I'll call it the classic flow, people will come here just before tape out and realize, okay, I've got some holes in my architecture. I have some issues, and I don't have to explain this to you guys. You all understand that, okay, when you get to this stage, to do a respin, there's heads that are going to be sacrificed, there's dollars going to be sacrificed, and you're basically going to come back to this first phase, right? So what the tool like Platform Architect does is it actually lets you do some early analysis of both your performance and power, right? So it's traditionally most users really focus on the performance. So here we're talking about performance in the context of your KPIs around your memories and interconnects, right? You're putting all your peripherals or your IP blocks together. You really care about, your memory transactions and the traffic across all your interconnects. So here, a tool like Platform Architect, lets you do your performance analysis months sooner. It lets you start analyzing your power months sooner to address both all your optimization of power performance as well as your area and cost. Now, this is just the baseline product as it is, right? And the key thing I want to put here when I say early analysis, there's this line right here, right? This line right here, early analysis means pre-RTL. I'm not even talking about RTL. So the key concept here is that it's all model-based. It's all System C model-based. Right, so the idea here is you have models of all your IP blocks that you can actually compose a system together and then actually run your workloads on top of it before you even get to any RTL. Right, and then the follow-on question I get all the time, well, what if I don't have a model? Okay, so then you either invest in creating a model or you go to an IP vendor, work with the IP vendor and say, hey, is a model going to be available? And then a tool like Platform Architect, we actually enable what we call RTL co-simulation. So if you have access to RTL, you can bring in the RTL into the Platform Architect simulation. But in general, it's basically a System C model. Just for full transparency here, if you do bring in RTL, it's going to slow down your simulation, right? That just comes with the territory. So there's a trade-off there. If you don't have a model and you want to use RTL, just be aware that you'll slow down your simulation. Now, coming back to this System C model, for those of you who are not aware, at a high level, this is now when we talk about virtual prototyping. This is really what virtual prototyping is, right? It's creating a System C-based TLM model of your system. Now, in virtual prototyping, there's really two main use cases. This one here, Platform Architect for architecture exploration. The accuracy of your models is very critical. It needs to have a lot of the timing information, okay? So any System C model that you use with Platform Architect, it has to be what we call cycle accurate or cycle approximate. So basically, it's a CA type model. The other typical virtual prototyping application that you might run into is for software developers. Now here, the System C models are what we call loosely timed. It's at a higher level of abstraction. You don't really care about the timing between all the different components. You just want to make sure that it's functionally accurate and it's targeted for software developers. Okay, so that in itself, and I see this all the time, like, well, I have my software developers and Platform Architect is a good tool. And you have to be careful. The use cases are completely different. The target audiences are completely different. But yes, they're both virtual prototyping tools. So one is for architecture exploration. The models are all cycle accurate. The other one is software development. The models are all functionally accurate and faster. So it's actually good where a developer can actually see the system as it runs, attach a debugger, and just go through the application debugging as online, right? So that's really the value proposition here, is to reduce your risk early, right? You don't want to come here and figure out that your architecture is messed up, or your bandwidths that you thought you were going to get are not actually being able, for example, right? So typically what we see then is that, in the different markets that we have, in the AI mobile space, they're able to do this 3 to 6 months earlier. So they start the activity here before even thinking about RTL and software development 3 to 6 months earlier. In the automotive space, some of the data that we have, it's almost a year and a half earlier before they even know, right? So what we're seeing today on the automotive, for example, people are working on this, the 2028 model car, 2029 model car. They're actually starting to use Platform Architect today. So they're starting to do this 12 to 18 months before they even think of RTL. So they start doing this in 2025, end of 26, they get the RTL and go to tape out for the 28 model year, right? So the other benefit to this is that you don't have to wait for hardware to be available to actually test your software. You can actually start running some of your software if it's available on a system like this. You can actually start doing some of your hardware software validation earlier. Now, the goal here, when I say it's model-based, it's not to get you 100% accuracy, right? I'm not saying you use a tool like Platform Architect, you guaranteed to get 100% accurate of what you would get with RTL. You still need to validate this with RTL at the end of the day. And the reason being, it's highly dependent on the model, right? So when you create your model, the model creator now needs to understand what is it that you're really trying to optimize for, or what elements of that model are actually important for you to do performance analysis. You may skip it. So typically what we see here is, at this stage here, using a tool like Platform Architect, the models are good enough to do 80 to 90% of your performance numbers. So it's a good leeway to start early on. But then at the end of the day, most companies who have invested in a tool like this, once the project has gone to tape out, they have this continuous iterative cycle. After they do an RTL emulation verification, they go back to the model, update the model. When they get closer to tape out, like, oh, we had some of these deviations, they actually go back and update their models for the next version of their projects, right? So it's an investment that they make. And so it's up to the user how much they actually want to leverage this, right? But not having a tool like this, especially in today's world with chiplets, is becoming crucial, right? Just because of the complexity, putting dies together and so on. So the next question then is, what comes next after this? So I mentioned the use cases. So it's not a single use case. I talked about the generic flow, but within architecture exploration, if you talk to architects themselves, there's different things that they do. Are they looking at an SOC subsystem? Are they looking at a full SOC? When I say SOC subsystem here, are they looking at creating individual components within that SOC subsystem? Are they looking at the core? Are they looking at the memory? Or are they just looking at the SOC as a whole? And then I can take that up to a high level of abstraction, and now looking at creating individual SOCs or individual chiplets and now combining them together into a multi-die system. And then I can take that even to a higher level of abstraction, basically a bunch of chiplets together in what we would call a network of SOCs. Right. So, and the reason that this is important is that on the y-axis here, we have this notion of abstraction. So this basically tells you what is the kind of abstraction you would need in your model. What is the fidelity of your model going to be, right? So for a network of SOCs, these are the kind of use cases that you'd be looking at. Are you looking at the dimensioning, the load balancing, and so on? When you get to multi-die systems and SOCs, you now really looking here at task level partitioning. Where do my functions actually fit on which chiplets and so on? What are my interconnect memories going to be? Typically, what we see most of our customers do here, they use a tool like Platform Architect. They come, well, I'm not sure which vendor I'm going to go with. I'm not sure what kind of IP I'm going to go with. Am I using DDR? Am I using LPDDR? Am I using HBM now? So those kind of, when I say IP selection, that's what it is. And then also within those categories, you're like, okay, well, do I go to a vendor A, vendor B, vendor C? They all have different characteristics. So you can actually come here and experiment with different types of configurations and so on. The other one here is at this level with SOCs and multi-die systems is, you're really doing L3 level cache and cache coherency optimization. And then what's new here with multi-die is, the analysis of the actual communication. Now, this is also dependent on a model availability, what's the die-to-die protocol that you're using, and so on. And then if you come down to the what we call the micro architecture or the SoC subsystem, this year you're really looking at very, very accurate models, right? It's very important for you to actually get this instruction level partitioning. You really looking at your L1, L2 caches. You really care about the performance of the core itself, things like that. So there's a broad spectrum of use cases within an architecture exploration paradigm, if you will, right? So people are like, well, I only care about this, yes, but the architects, and you need to understand which use cases you actually drilling down into, because that actually helps you define the what we call the fidelity of your models. Okay, so this is just some of the, you can translate this into the types of workloads that you would actually need. And so the tool like the Platform Architect actually enables you to import different types of traces for your workloads and so on. I will skip this section here in the interest of time. Yeah, so the point here is, at this point here, you really need to have very accurate models, right? Very accurate cycle models of your system when you're going down to the micro architecture level. Now, with all the, in the last 2 years, all the companies doing chiplet-based designs, they now at this level. They always here really focused on the workloads. How do I import my workloads into a tool like Platform Architect, create the biggest system, and then actually do some analysis. So on that side, this is typically the use case over here, the application workload model, where you're mapping the now again also the requirements at a high level obviously translate down to the lower level, and you can actually feed that back and redo calibration and integration as your model and your exploration proceeds or progresses along the timelines. Just a notion here on supply chain. So a tool like Platform Architect, it's really working across an ecosystem, right? There is no one individual vendor that does everything, right? So typically you'll have a use case or a workload that's being defined by a system company. They exactly know what are the workloads they need to run. They know what are the cost performance. They typically will send that out to what we would call a semiconductor company or the semi. Will actually take that workload, create the base platform, and run it, right? So there's different notions here of sharing the architecture design amongst the whole ecosystem. So, and this is typically the flow. If you look at automotive, there's actually there's a middle layer here of the tier ones, right? So you've got the OEMs, the tier ones, and semis, and you sort of see that in all industries. Except for like mobile consumer, where there's just one vendor that does it all, right? It's just because of the time to market and the complexity is a little less. So this supply chain collaboration is very important, and that's why a tool like Platform Architect actually enables the collaboration, right? So what we have system companies use Platform Architect, they just get what we would call the reference hardware platform and run their workloads, and vice versa. We have the semiconductor companies here get some reference workloads from the system companies, actually compose the system itself, the hardware platform, and actually run, and then they share the results. Okay, so it's not just a single vendor. You have to really think about where in the cycle is this, and it's just completely iterative, right? It's a continuous loop that goes on and on between all the all the players here in the ecosystem. And so, like I said, so it's basically the workload model requirements get shared with the semis, and the platform model and the analysis results go back up to your system company, and that loop can go on forever, right? Just iterating across different variants of product releases. Now, so that's really an overview of Platform Architect in general. Now, moving to multi-die, if I look at the monolithic SoC, I talked about performance and power. There's really new challenges when we move to multi-die chiplet systems. Because you've got homogeneous disaggregation, you now actually have heterogeneous system integration. These are two new use cases specifically for the chiplets, and they tie together with the die-to-die, right? What is the die-to-die protocol that you're using? So this element here is key, especially when you're moving to multi-die or chiplet architectures, whether you're either doing disaggregation or heterogeneous integration. And then once you've decided what is the actual use case, you've decided on your die-to-die connectivity, again, you're going to come back to the traditional architecture considerations, right? What's my memory utilization? What's my cache coherency across all these different chiplets and so on? Then you actually need to verify the system performance there against, full verification. And one thing that's new here that we never used to consider when we were doing monolithic SoCs is thermal. Thermal now is becoming critical, especially when you're doing 3D stacking. How does this affect the performance? And so this is something that we have on the roadmap. Obviously, in the ideal situation, we would have thermal system C models, but there's other ways. So for example, we could, leverage some of these 3D IC tools that already have some thermal analysis further down the line where we could actually translate that data, bring it back into Platform Architect and reiterate the model so that we can actually get some thermal analysis in as part of the whole performance calculation. So basically finding out your different hotspots and how does that affect some of your memory transactions and so on. So we started seeing companies look at that. And so that's definitely something new and something that's becoming very, very critical as we move along with the chiplet architecture exploration. Right, so these are new challenges going from monolithic to multi-die. And so you can just break those down. Actually, I don't even just spend time on this one. These are the actual use cases we see customers doing, right? It's partitioning. I've talked about it. How do you distribute your functions? And then again, here, the selection of standard chiplets. So here, I guess at OCP, you guys, there's this big notion of a chiplet ecosystem, right? And I think this is where the market's going. A tool like this is, okay, in this ecosystem, can I just replace certain chiplets within the ecosystem and do some analysis? How does this affect my performance, power, and so on, right? So this is what I think is actually relevant to what you're doing here with OCP. The selection of the die-to-die protocols, interconnect IP, are you using cache coherent, non-cache coherent? Are you using these ARM CMNs now in your system? Are you using XSR, are you using UCIe, whatever it might be? The other thing I did not mention, when we talked about models, out of the box with Platform Architect, let's say you're starting a brand new project, you don't even know what IP you're using. So we provide just what I would call starting models, so generic models of everything, and especially, so we'll have generic models of your memories, we'll have generic models of your interconnects, and we'll also have generic models now of your die-to-die, right? So you can now change those parameters to suit what you think your IP is actually going to be. So as a starting point, you can compose a system with these generic blocks that we have. We have a generic, what we call processing unit as well. So it's a virtual processing unit if you're not sure on what the actual cores are that you're going to be using. Okay, so these are some of the use cases that we see some customers in the industry using. So this is actually a nice slide. I like it because it basically distinguishes between the your typical SoC or chiplet design versus, now putting a whole multi-die system together. Right, so, all these years people are looking at these kind of decisions, and now when you move to multi-die, what is the effect of aggregation, disaggregation, the different die-to-die interfaces, the different packaging technology. So here at Synopsys, we're trying to augment the flow here, where we're trying to look at some of the floor planning criteria, some of the thermal criteria, putting that back into a Platform Architect and trying to automate that loop with other tools downstream. And this is here related to the packaging technology, right? So you can start taking those considerations early on in your design cycle, at least at a higher level, and get some early analysis. Okay, so with chiplets and multi-die, for me, it's actually it's a very clear cut line, and the use cases are very clear on what you can do here with chiplets and how this tool now is really being adopted on those doing multi-die designs. Okay, and then just a simple example where I just take my monolithic SoC. Let's just take a memory block. The tool lets you say, okay, just put a cut line here and just see what happens and rerun the simulation. Right, it's that simple. So you can say, okay, insert a die-to-die interface at this point and rerun the simulation. Right, you can do that in like less than 2 minutes. So things like that are very powerful and gives you that instant dynamic analysis right away. So. Okay, so on the chiplet side, it's really about partitioning into dies, chiplets, and it's very critical. And this is now, I think most of the architects like to spend their time. They don't really care about all the different connectivity blocks, but where do you actually put your different functions, and how is the system actually going to scale? The second one here is actually, and then how do you optimize for your bandwidth density, all that good stuff, based on your IP selection, right? Based on the different vendors' IP blocks that come into the system. How then can you, once you decided your partitioning, how then do you optimize the actual system itself? And then finally here, it's really to, you have an idea, how do you actually accelerate the architecture realization? Okay, so I'll skip this one here. I'm going to skip UCIe. I assume you all know what UCIe is. So we actually support Synopsys. We actually support a model of Synopsys UCIe now. The RTL was released, so September release, this will be fully available with the product. I sort of talked about this. Let me just go to this one slide that talks about the actual flow. Okay, this one here. So when you use a tool like Platform Architect, there's really three things that, I think I mentioned. There's three things you want to consider. One is the actual application workload. The second one is the hardware platform. And then you're actually doing analysis when you combine the two. So, on the application side, we have a tool here. Right, so there's different ways for us to be able to import your actual application specifications. Let's say you actually have software traces, Linux F traces, Android traces, Tensor Cafe, Onyx traces, whatever it is, we are able to import those into Platform Architect in the form of what we call workloads. We convert those to what we call task graphs, which then get mapped to the actual virtual processing unit. So that's the first step anyone would do with Platform Architect, is analyze or be able to import your workloads. And then just if you care about your workloads only, there's capabilities there. There's analysis tools that let you actually analyze just the workload trace and statistics, if that's all you care about. The second one then is really about the hardware itself, right? So based on all these different hardware models that we have, working with different vendors, so we have a broad suite of models. So we work with all kinds of vendors. On the interconnect side, we work with ARM, Arteris. On the CPU side, obviously Synopsys. ARM used to provide CPU models. They don't anymore. On the memory side, obviously we support a lot of the Synopsys models. And then now with UCIe, you actually support the UCIe. But again, if you're not using Synopsys UCIe, you can still use the generic die-to-die library that comes out of the box with this tool. We also support power models and characterization. So here, the power models itself are based on what we call the UPF3 state models. So it's not really System C, but it's really a state-based power analysis, and that's the way you get that. So this is typically provided by an IP vendor. So once you have access to your hardware model libraries and your power models, you compose your system, right? You compose your actual design. So this is just an example showing a basically 4-chiplet system. These are the individual chips. And once you do that, you basically map. This is the key point. You map your workloads. As the architect, you decide where are those workloads going to run. You decide what are the CPU loads that are going to run those workloads, right? So this mapping then is actually very key. Once you have a definition of your workloads, you have a definition of your hardware, you connect the two by this mapping function, and then you can actually run your dynamic simulations. And then the analysis tools on the end, now you can actually start doing all kinds of root cause analysis, start measuring your memory bandwidths, latencies, all the transactions across the different nodes, and so on. And then the third piece here is looking at what we call design space exploration. So if I just look at, let's just look at UCIe, right? There's lots of parameters in UCIe. A question an architect might have is, what if I just change one of those parameters, between the flow of the different chiplets, your C2C link, whatever it might be. So here we have this notion where you can, either by script or whatever, create what we call parallel parameter sweeps. So you define your set of parameters, and where you can sweep across them, you can change those parameters on the fly. So you don't have to manually go in and, after each simulation, edit, rerun. You just kind of do that in what we call a parallel parameter sweep. Now, this basically gives you, the idea, say, okay, we have these what we call sensitivity charts, right? Okay, if I just change my memory bandwidth from 8K to 16K to 32K to 64K, whatever it is, what is the effect of that on the whole system? And this is basically what we call the sensitivity analysis tool in memory bandwidth in that case, right? So this is the notion of design space exploration. So it's not just one simulation that you run, but you can now potentially run thousands of simulations across your parameter space. So this is really explaining the flow of the tool and how it works. Let me see, it's 9:01. Should I keep going or shall we take questions? Raghu. Let me see what more I have here.
Raghu,
Actually,
you're
I
on
have,
mute.
I
Yeah.
have two more slides. Let me.
Yeah,
sorry, go
let's finish it off. I think I was wanted to just have you run through the whole thing, so people, if they did drop off, they can drop off. Just run through your material, and then
Yeah,
we
I
can.
just had two more slides. One
Yeah.
on just like what does the tool look like? So there's this notion of, obviously the requirements. That's the first thing you would do. You specify what's your read, write, what are your transactions. This is all in the tool. The next thing you do then is, actually select and extract your KPIs from those requirements. So the architect, this is all what they typically do in a spreadsheet, right? What are the key performance indicators that are important to them? You basically link those KPIs, the slide's going to those requirements at the high level, right? The high requirements came from some functional spec. And then you then you basically can actually see the requirement status every time you run it, right? It will give you a green, red, yes, these requirements were met, these KPIs were met. So at a very high level, the architect can quickly say, okay, that configuration just didn't work, or those parameter sets didn't work. And you can go back and change them as needed. So at a high level, this is what we see. This is what we see architects doing. Now, some of you may have seen some other presentations that are done with AI. I'm just going to throw that in there. So we are adding an AI engine in the back where we just say, at this very first step here, I'm going to give you my requirements and KPIs. Go ahead and run and find me a solution. Okay. So this is the AI engine that's coming in this tool at the end of the year, where it's just a simple reinforcement learning today, where we just say, here's your requirements, here's my parameters, go and find me a solution. Don't run the full entire design space. I'm going to say, okay, I'm going to constrain your design space. Within that design space, find me a solution. Whereas today, architects, like I said, they're going to look at the results in a table like this, like, okay, green, red, and they're still going to scratch their heads and kind of do some extra work on it. So that's coming next. I did present something at DAC actually this week on that, if you guys have access to that, in the E times Chiplet Pavilion, just introducing this AI flow in this whole parameter sweeping type context. Okay, so that's really from the architect perspective. And remember, everything here is pre-RTL. This is all done months before you even get to RTL. And that, I need to emphasize that all the time. This is really the value proposition you have a tool like this. And so here, I'll skip this. This is all the different models that we have. We work with lots of different vendors. One thing that we've seen actually an uptick in the community is with Gem 5. A lot of people are investing in Gem 5. And we do have a co-simulation with Gem 5, so we've imported a co-simulation with that just in our previous release. The rest here, I don't think it matters. It's just know that we have a broad library of different models from different vendors. This is basically a repeat, so I'll skip this one. You don't really care about the details of that. By the way, notice that we are not, I support Tensilica models also. I support competitive models if the customers demand it. So, I'm not shy to advertise that. So, it's not like it has to be Synopsys and Synopsys only. No, it's whatever the market requires, and we work out agreements with whoever it might be. And then this here is just a screenshot here. This is exactly what your layout in Platform Architect will look like. So here's again a simple system where you have 3 chiplets, an AI chiplet, a CPU chiplet, a GPU chiplet. You have what we call the central NOC chiplet, and then these 3 these red blocks are all your die-to-die interfaces, right? So now you can go in there and actually specify the characteristics of those die-to-die interfaces. This particular one also has HBM3 as the memory block. You can go in and specify the parameters of those memory blocks. Now, again, coming back to that AI conversation, this gets complicated very quickly, right? Do I need to be an expert in die-to-die? Do I need to be an expert in HBM3? Do I need to be an expert in NOx? And, the expertise level just exponentially explodes. And, tools like AI in the background can really help now trying to hone in on a solution, which, yes, would still need to be validated again by the architect, but it helps constrain the design space. So, this is really what it looks like. You capture your workloads. So in this case, the AI workloads are done here by what we call task graphs. The CPU workloads are also done by task graphs, and the GPU workloads, you can time in there and actually specify the parameters of what that actual task is doing, right? What's the read transaction, write transactions, and so on. So the level of complexity, it's up to you as the architect to decide how deep you want to go. You can always take the generic values, but the capabilities are there because you really care about, the timing accuracy across all these different components in your simulation. So, and then this is just a quick screenshot here of what the output, the analysis tools actually look like. Things that you can measure, the bus throughput and so on. So, yeah, I can stop here. The rest is just, I'll send these slides to you. The rest is just, existing customer success that I can talk about. We had some webinars with ARM. We had Altera talking about using this tool last year publicly, how they actually using a tool like Platform Architect, an anonymous company actually putting a more complicated system together with, 8 multi-die systems with optical links. So it gets very complicated very quickly. And, I think the architects today are actually getting overwhelmed. We had a company like Telligence was one of the early adopters of this before we even had a release. They used a Platform Architect for the optical multi-die system. So, enough of the marketing stuff. All right, I'll take questions now.
No, it's very good, Kamal. Thanks for, I think for me, it was also very enlightening. I mean, even though I did a bit of reading and I attended your session Chiplet Summit, but this is like, I think every time
No, and this is also still a high level overview, right? The next thing we typically do is we get our AEs, like just sit down with a design, go through the tool, and what are you interested? Are you interested in the workload aspect, the actual hardware platform creation aspect, combining the two and actually seeing simulation results, or...
Yeah,
so
no, it's good. No, thanks. That's very good. I think it's a very good level, I think, for today, for this audience. So I think let me open up. So questions, we can spend 20 minutes or 15 minutes or less.
Hey, Kamal, sorry I missed your, I actually had a 8:30 call, so I think I missed the most of what you said.
No problem.
So I've got, let's say, a system that is already pre-done. So let's say I've got 2-3 chiplets that are manufactured by different companies. Let's say that I have like an Ethernet IO chiplet made by Credo Semiconductor, because that's one of the people that's listed on our website, right? I have something from ARM, let's say, or whatever, right? So now I'm going to build my own chiplet, right? And I've got standard chiplets. So how would, I mean, I see this as great when you have, I'm designing the entire system from scratch, right? The challenge we have in this sort of group is, okay, that market is already well served, right? Because that's very large companies, right? Now, there's another group of companies saying we want to reuse chiplets, right? And how do I even know that this chiplet will talk to this chiplet, right? How do I get to that point? And I'd love to hear your input on that aspect of this, because this is, but from a big picture standpoint, that's what's driving our conversation with our group, right? Because we'd love to work together to find a solution for that. But the second part is, as you know, I want to use a Credo chiplet, and then I want to get some representation of that. Well, they're like, read the damn data sheet. Okay. And that doesn't get us very far, as you know. And even getting a data sheet is very difficult, let alone RTL or any of these nice So what's your thinking on that? Because that's actually I think that's a much harder nut that we're trying to sort of socialize and get input from vendors like you or ideas on how to make it work.
Yeah, so let me take the first one. I think you're hitting on more what we call standardization, right? You talked about, how do they communicate, right? So, Arm or whoever it is coming out with this, this CMN C2C protocol. Is that the industry standard? But we're not proposing or propagating any particular standard, but whatever standards are being adopted out there, we will implement in our solution. So here, when you talk about communication across different chiplets, how do I guarantee it? I don't. I give you a block. These two red blocks are my die-to-die interfaces. I give you, as a starting point, a generic block that says, okay, you can start modifying those parameters to maybe mimic what the industry is talking about. And then, so we've worked with companies like GUC who had their own XSR implementation early on. We've now just basically said, okay, we're going to go with UCIe. So the first one we're going to have is Synopsys UCIe as the die-to-die interface. So having these kind of vendor available models, and hopefully, like, for example, UCIe, right? To me, that's becoming the default standard, if you will, as far as chiplet communication. So as long as the chiplet vendor adheres to that, it should help, right? The second question you had was on the Ethernet IO chiplet, then you're having a hard time understanding what's actually in there. On that one, I have no comment, right? That's between you and the IP vendor, right? So you need to work with whoever created that chiplet and
so what would they need to provide you? Or what should they
so
provide
you really
you?
missed the beginning, right? So this is all system C. Ideally, it would be system C model.
Okay.
Right. So I think I mentioned this. So typically, every IP vendor is the source of the model, right? So whichever, like I said, we work with this broad range of IP vendors, they typically provide a system C model. Now, in some cases, they don't, and I also mentioned this earlier, but you have access to RTL. So instead of having access to system C, you can co-simulate.
Let's forget RTL. That nobody's going to give you RTL. They may give it to Synopsys, but then it's a general.
Yeah, so then in general, the flow would be the IP vendor should also create a system C model. Now, most of them do, and not only for platform architect, for everything else, right? You've seen like in HLS systems where some of them output system C that actually go into some of your RTL generation tools. They use system C for other purposes, right? So it's typically the IP vendor that we need to work with and, say, hey, can you... Now, I also mentioned within System C, right, there's different types of what we call abstractions. So in a tool like if you're doing architecture exploration, you want to make sure that model is at least cycle approximate or cycle accurate, right, at that level to be able to, for it to be useful in a tool like this.
Right. So could you
hold on. Sorry, Kash. I mean, just to be sure, let's open up to other people. In case other people also had some questions, I just want to be fair. So is there any other questions besides Kash? Any other questions?
I had one question. So Kamal, you mentioned at some point that you support these generic die-to-die models.
Yes.
But then you also said that, tweaking a parameter here or a parameter there for UCIe, because there are lots of parameters that can be tweaked to make it, to optimize it. So how does a generic die-to-die model handle this? And when you say generic, does it mean, say I've decided to use XSR and not a parallel interface? So does it like accommodate for serial versus parallel type interfaces, or
Absolutely,
I could do
absolutely. So here's an example right here, right? This is the generic die-to-die. You can actually, with each of these elements of the die-to-die model, you can specify, is it going to be UCIe type? What's the actual protocol, axis, serial, what are the number of interfaces, and so on. This is just the list is a little longer, but within that, it gives us a way that's close enough to what you want to specify. So we've looked at just a typical die-to-die interface and what would be important for your performance analysis, and all those parameters we've captured in that generic model.
Okay, so if I was doing a modeling of a bow and I know Synopsys does not support the bow, what would I do in that case? I mean, it is a parallel interface like UCIe, so in theory, I could just put UCIe. Is that what you're saying?
Yes, in parallel, you could do that. So there's blocks in there in the generic one as well that you can customize it to add whatever functionality you want. But you need to know on how to, create that API. But it's in there as well. That's not part of, if it's not part of the generic component.
Oh, I see. Okay, so I could take one of your generic ones and then you're saying customize it, but I need to have some kind of knowledge to be able to do that.
Yeah, but it's not that hard, right? So with the generic one, you just have to understand the interface, just the TLM interface. And if you don't understand it, we can, and if we feel that it's critical to all die-to-die interfaces, we'll implement it. So typically when we first came out with this about 2.5 years ago, we were like, who's out there that actually knows what a die-to-die interface should look like? Yes, we have an opinion, but as we put it out in the market, we get feedback. Okay, you need to add this parameter, you need to add this parameter, you need to add this configure. So as time goes, we've been enhancing that die-to-die with most of the common elements, if you will.
Okay, thank you. I appreciate it.
Yeah.
I have one more question, but I'll let someone else go.
Yeah, just wait, hold on. If someone else has, then we'll come back to you, Anu, and Akash.
And I think it's important, right? So for 2 years, all we had was this generic die-to-die, and we had lots of customers adopting this. We didn't have a IP specific die-to-die model.
Right.
Everyone was just happy using this generic one. So
Yeah. No, I think for like pre-RTL level, you're talking systems, really high up in the hierarchy. I think it's good enough to know how many slices.
And so
of code you
typically
have.
then, what we do now, people say, okay, I have this version of a particular IP vendor's, a particular version of the IP. It's this particular version of RTL. We will actually go back and say, okay, now this model is aligned with this version of RTL. So this is what we will do, for example, with the Synopsys UCI. You say it's aligned with RTL version so and so, right? So now we guarantee that it's exactly accurate. So
so that's getting kind of deeper into
right.
Yeah. Okay.
Once you've
With more
decided that
parameters.
is the IP block, you don't want to mess with it. You don't want to configure it, and that's it. Then that's going to be going forward for all your designs. So
Right. Yeah, that makes sense. Thanks.
Yeah.
Next person, anyone else with questions?
Hi, Kamal. Hi. Can everyone hear me?
Yeah, Chooks. Chooks. This is Chooks.
Yeah,
go ahead.
Yeah, great presentation. I really enjoyed. I've been working. I mean, I recently started looking into platform architect. Recently, but not the multi-die. Not the multi-die version. So, my question is more about kind of similar to what Anu asked. But more specifically about high-speed serial interfaces for like JSD, for example. So I wanted to know if the die-to-die interface that you guys have modeled kind of also supports like JSD or like more like high-speed serial interface for like converters, that kind of stuff.
No, we don't. And no one has asked us for that. So you're the first one. And the other reason might also be is how important is that for performance analysis, right? So
Yes. So I mean, so from most like companies like from like mine, like analog devices, we deal mostly with with converters, right? So we are also trying to look into how we can model this at the system level, right? Before we actually get into the RTL, like to get into the physical design flow, right? So one part of it is having like accurate system C models for like what's just the like die-to-die version of the interface should look like, which is actually what I'm working on, but I wanted to know, and actually I'm not even right now. Initially we were using platform architect, but we have to pedal back a bit, and then because we don't have like support for like just the interface, like modeling that in platform architect. So I wanted to know if there are any plans or ideas
so on
around
that
this.
one particularly we don't have, but it's probably because no one has requested it from us. Now the other thing, do you have this from a particular IP vendor? So that model should come from the IP vendor, right? It shouldn't come from us.
Yeah. So most of the interfaces, from what I understand, it comes from within the company, right? So we do have, the IP within us. Like we have designed some of the interfaces. Like what's most of the so we have products which we are trying to model, but how that interface should look like is mostly a custom interface, really. It's a high-speed custom interface that kind of looks, it's basically just so but how to model that using platform architect is still still an open question, which I wanted to ask.
Okay. Yeah, I would suggest, just get in touch with us and we will take that down as a requirement and look at it for the next iteration. So, but I know today I've not seen this on my roadmap at all. So
okay.
Yeah.
Okay.
But that doesn't mean it won't be there, right? So just get in touch with us and we'll put it on there if we see that this is a future requirement and there's going to be a market need for it. So
Chooks, if you want to connect with me, or I can connect you to Kamal. I have his email.
Okay.
And his phone number and his residential address also. I know where he lives. So if he doesn't give you that feature, we will chase him down.
So he says he's from Analog, so I can already find out what he's doing with Platform Architect if he's still using it. So I do know Analog, ADI. You guys are pretty much. Is it ADI when you say Analog?
Yes, ADI.
Yeah. Okay. So I know what you guys are quite big users of Platform Architect. So
good. Okay. Hey, so any other questions? Others rotate back to Cash and then Anu for the last 2-3 minutes, 5-7 minutes. Any other questions besides the other two in line? Okay, last call. All right. So I think Cash, back to you.
Yeah, I just wanted to suggest if you could help us write something up about, hey, we need the IP vendors to do this, and it would make it easier, not just for Platform Architect, but just help the industry along, if that makes sense. System C, the type of System C, as you know, there's as you mentioned, different versions of it. And the second thing was obviously taking the ADI example, right? They have JESD, which is a digital block that drives a serial PHY, right? I believe that your serial PHY does actually support JESD. Okay, because you do have that, like your 56 gig or 100 gig SerDes will. And how would somebody import that, or do you have the ability to import that from different people? So that's what I was trying to get to, was we're at the early stages of trying to figure out what the ask should be. Maybe your tool does everything. If there's a gap, that would be good to know. But in general, how can we help? I mean, at one way of looking at this, this will help drive business for products like yours, right? Where people are now, okay, what do we need to have all the chiplet vendors start thinking about, the 5 vendors start thinking about? So that's all I was going to add, was I think that, not expecting all the answers. It's just, I think it would be helpful to get input from you and people like Cadence or whoever else is doing this, and help the industry along a little bit, right? So because right now, I think even though you say the System C models exist from everybody, I'm not sure that's the case on the PHY side. And ideally, as you say, they should. Credo, I'm using Credo as an example. If they want to sell their chiplet, this should be a requirement. It's like IBIS models are a requirement if you're in that business, right? So how do we get to that point? So that's all I wanted to leave you with, was that comment. Because I think we need help and clarification.
Yeah, I have 2 comments on that one. One is, first we got to look at all these, what I would call peripherals on the side, and how do they really affect the performance of your system? And in some cases now, actually I didn't even mention this, we typically, when we work with some new design, new implementation, we kind of replicate these peripherals just as traffic generators, right? Just as a traffic generator, as a block that can run on the CPU. So if you know the traffic patterns that are going to be running on these blocks, we just replace it with a traffic generator, even though we don't have a System C model. Because at the end, you got to remember, right, it's a workload that you're really running on some type of CPU, and you want to see the effect of that. So if you can mimic the activity on whatever that peripheral device is by just a traffic generator, we can do that without actually having a system C model and so on. So that's another workaround, but I think we should look a little bit deeper into it. And as far as writing something up for you guys, as we started talking within Synopsys, I went back and I was like, okay, wait, we sponsor OCP, but I'm like, the activity level is pretty low. So we probably need to elevate it. And maybe that's an action for me to go back and look at the higher level Synopsys ecosystem and, actually get something that I don't mind writing anything up as well that promotes. So in Europe, we work with all these other vendors like IMEC and all these research organizations pushing all this chiplet and technology as well. So I don't see why not. So
last comment from Anu, and then we'll close it out there. Thanks, Kamal. Anu?
Yep.
Yeah. So no, I was just interested. You showed that was it Light Intelligence who
Light
did a
Intelligence, yes.
modeling with you? So it's kind of. I just wanted to know how they did it. Did they have their own models for the optical modules, the EIC, PIC? Is that what they had, or is it from your library, or
Yeah.
like just high level?
So very high level. So they were very early on before we even got to this stage, right? We were working with them about 2.5 years ago, and they basically helped us design this product and what's really important. So the modeling piece, they all had in-house, most of it. And this piece about traffic generation, for those pieces where they didn't have models, they just simulated the optical traffic as inputs to all these CPU elements.
I see.
Yeah.
Okay. No, just interesting because I think that's the next buzzwords, next wave of things to come. So I was
Yeah.
interested to see how they use your modeling tool because a lot of stuff is so specific to the optical engine and the stuff they do, the waveguides and all of that stuff.
Yes. Okay.
Good.
Thanks, Kamal. Really appreciate you coming
good
and
timing.
Presenting.
So I
No
think
problem,
Kamal looks like
anytime.
you have said you can share the slides. I think Chooks also has made a request on the
Yes,
message.
I can share the slides. Let me just
So, yeah,
wrap
so-
this up and send you.
Yeah,
a PDF
email it to
version.
me or Anu. You have Anu's email, my email, and
Will do.
Anu, if you can, I don't know, post it on some wiki or something.
Yeah.
That will be.
No, hey, I have a new method to the madness where I've got a folder for the recordings and I've got a folder for the presentations, and I think everyone can access it. So,
So,
if you
yeah.
send it to me, I will put it up there and then I'll send the note out to everyone in the group's IO.
Fantastic.
Okay. I'll get
Fantastic.
that out to you. Yeah.
All right. Hey, thanks very much, Kamal and
Right, no
Rashid.
problem. Let's
Wonderful.
get this going.
We'll
Yep.
stay in touch. Let's stay in touch.
Okay. Yeah. Thanks.
Hey,
Okay.
Kamal,
Don't
thank
worry.
you, man.
Right.
Yeah.
Thanks, everyone.
All right. Bye.
Bye.
Bye. Thank you.
Bye-bye.
Bye bye.